Okay, so tonight we're going to build a very common thing, which is like lots of the beginners tutorials are all about this. But what the hey, we're going to do this, and hopefully it's going to end up being kind of cool as we go through things. So primarily this is about me getting into op amps and for me to learn bits and pieces about them. So we're going to start with the simplest thing, but the circuit that we're really going to be looking at is the light detecting thing. So there are many ways of doing this, and using op amps is probably not the best, but I think using them this way is the easiest way of understanding things. And at the core of this circuit, so I've got black felt tip pen on my fingers, is going to be this thing here, which is an LDR, or a light dependent resistor. So all this is just a resistor that has its resistance change as light levels change. So I'm going to start off first by just attaching a orange. Should I put in a? I should put in a little 100 ohm resistor if there's one sitting around. Okay, we'll put in one of these just to be on the safe side. I'm going to put that across to, that's not the best way of doing it. Hold on a second. Alright, so that's a 470 ohm resistor. But basically I made a circuit with my little LED, so the positive voltage is going through this resistor, through that wire, into the LED, through the long leg, so the anode, out through the cathode, into the variable resistor, and down here. So as the light changes, the amount of current going through here is also going to change. I put this in just so that the current is limited. I know the current never gets down. The resistance will never get to zero, so this is pointless. So we might take this out in a second, but let's just see what happens. I've got my covered in sellotape, so hold on a second. And now it's all over my fingers. Sorry, this is my bike light, which I taped to my bike because I haven't got the mounting bracket thing at the moment. But anyway, we'll use this to shine directly into the lights because there's a lot of light around here. So let's just find out. This is going to make it very hard to see. What we should do is we should put that one there. This makes a lot more sense. So, well, which voltage have we got? 5 volts going through here, and then that one's going to there. This way we can kind of keep, because I want to keep the light dependent resistor as far away from the actual light that we're going to be turning on as possible. So let's just activate this. So if I turn the light on, it actually gets brighter. So if you turn it off, it gets dimmer, which is very hard to see. But actually, if you do that, you can see that as I move closer, it gets brighter. I don't know if that's probably not showing up at all in the camera, but if I take it away, and if I cover the whole thing up, the light goes up. Even if I turn all these lights back on, it's pretty good at seeing through your finger, but you can see that it does. That's actually a much better way of showing it. I just should have done that in the first place. So that's kind of interesting, but it's still kind of on with my fingers there, and when I take it off, it's still, you know, it's not as cool as we want. And also, maybe I want it, and it makes a little bit more sense that when it is dark, that I want the light to come on, and I want the light to go off when it's light, which is the opposite of what is happening at the moment. So we can do a circuit kind of like this. So this is this is my badly drawn symbol for a light dependent resistor. So it's just a resistor that's inside a little circle with little arrows pointing. That's the light coming onto it. The opposite of an LED. And in here we've got two little circuits which are not going to be, which is kind of like what we've just done, except the resistor part here also has an LED in it. But the important thing is we're going to be looking at this as though it's a voltage divider. So over here we have our positive voltage and our ground. And we have a fixed resistor here that's not changing, and we have another resistor here that is. This is the light dependent resistor. And so the important thing is, at this point here, if the resistance of this is changing, then the resistance here is changing. I mean the voltage here, sorry, is changing. So the voltage that's at this point here is going to be different depending on what the resistance is. So the resistance here is low, which we get in this case when it's bright. Then this voltage is going to be high in this case. It's going to be closer to here. So there's going to be less resistance in comparison to this resistance. So there's most of the voltage is going to be used up going across that resistor. If this is low, but if it's high, and it's low when it's bright, but if it's high because it's dark, then this is going to be higher in comparison to this. So more of the voltage is going across here and less is going across here, so the voltage will be lower. And the opposite will be the case around here. So in this case here, when this one has a very high resistance because it's dark, then the resistance is going to be low. And over here, that's not right, the resistance is going to be high because in comparison to this one, so let's just say this is 100 ohms, and let's just say we cover this up and it's dark, and then the resistance is say 1000 ohms. I don't know what the values are on this one, we'll have a check in a second. Then most of the voltage is going across here. So let's just look at this, the examples when they're dark. When this is dark, this is a high voltage, that's low. So this voltage will be low because most of the voltage is spent across here. In this case here, in this circuit. In this case here, most of the voltage is spent across here, so this voltage is going to be high. So let's flip these things around. This is going to be important a bit later on because we might want to swap things around. But for now, let us go to the next part. So the next part I'm going to briefly introduce is the idea of an op amp. So op amps look just like ICs because they are. So this is an op amp here. So this is the op amp we're going to be using. It stands for operational amplifier. I think originally they were kind of designed for analog computers. So I think that's where the operational part comes from. I'm not entirely sure. I don't know. But they do kind of amplify signals, so that makes a bit of sense. But we're not going to use it as an amplifier today. We're going to use it as a comparator. But first, so this is the symbol for it. Usually they don't always put these bits in on their circuit diagrams, but there's a positive and a negative voltage supply going into it. But the important things is there's this non-inverting input and inverting input, and so they're marked as plus and minus. We're gonna look at them like this today. And then there's an output. So two things go in and one thing comes out. There's a kind of interdependence on this when you use it as a proper op amp. But if you're using it as a comparator, then basically you just have one voltage at this point and one voltage coming into here. And if this voltage is higher than this voltage, then the output will go high. And if this voltage is lower than this voltage, then the output will go low. So that's kind of all you really need to know for an inverter for now. But then one more thing we need to do, we need to know about a potentiometer. So there's lots of things being introduced today. So these are kind of symbols for potentiometers. They're kind of like variable resistors, except they're sort of more mechanical. And this is an example of a potentiometer. In fact, this is the easiest way of seeing it. So how they kind of work is there's a resistive material there, and you've got voltage coming in one side and current coming in one side and going out the other side. And then you've got this little slider thing that moves backwards and forwards, and that's sort of tapping into the resistance. So at any point, which is what this little arrow is, it's kind of acting as though you've got a voltage divider. And so there's some resistive stuff here because you've like that bit on the side, and there's some resistive bit here, and then you're sort of tapping in and reading the voltage at that particular point. So it's like a potentiometer because it's reading the voltage potential at different points as you move along. So I don't know exactly how this is wired up, but I'm assuming this is like the two wires that go onto the side, so your voltage, so there has to be a voltage difference between here. So one side might be the positive voltage and one might be the ground. And then I'm guessing that these things here, so I can't remember what they're called when they've got two ways that you can read it twice. It might actually, be interesting to see what the voltages come out of this. But anyway, the other ones are this kind. So they come like this, and there's a whole bunch in here, and they come like, and these little tiny ones that go on your breadboards or in your little tiny circuits. But I think I'll probably use this one because I've already used it, and it's got these nice little pins that go here. So all you have to do is turn the little screw, which is pretty tiny, but I'm pretty sure my screwdriver's around, so we can try that. But the point for this is we are just going to create this circuit today. So we're going to see how this works. So here's my op amp. This is upside down, is it not? It is upside down. Okay, so here's my op amp. So over here I have my little circuit that I just drew before. So there's going to be a positive, I didn't draw in the voltages here, but there's positive voltage at the top. I've lost my felt tip pen, so I'm just going to write plus, plus, ground, ground, and red. This smells very strange, this felt tip pen. It's very toxic, that one. Okay, so here's my light dependent resistor, and here's a normal resistor, a fixed one. And so this is going to create a voltage divider that's going to change. The one thing about op amps is you can kind of pretend that these things don't use any current, and so they're very high resistance, and so they're not really affecting this part of the circuit at all. They're just reading the voltage. So this thing here is reading the voltage at this point, so this will change as the light changes. And over here we've got a potentiometer, which is also acting as a voltage divider, one that we are changing like this. So we are creating a voltage that we are reading in at this point. And as we change this voltage, we're sort of changing the comparison point. And this is just going to be important because if we can do this, then we can adjust the sensitivity of our voltage of this voltage divider, of this whole circuit, of the light dependent part. You'll see what I mean. Not so cool. But anyway, the first thing we have to do, it will make a lot more sense when it's all built. I'm going to take this away for a second, and I'm going to take away this, and number one thing, take these out for a second. We're going to need these. So we're going to attach to the output of the op amp an LED. So today, so you're going to make an LED, come on. Here's the data sheet for the LM324. It actually has 4 separate op amps in it. So we are going to, which is important because we're going to be using these, and we're going to use all of their op amps later on to make interesting little circuits, including perhaps our first oscillator for yes. Have we made an oscillator yet? We haven't. We just use those little tiny whatchamacallit chips, boards, modules. Okay, so I think it goes this way. I'm going to put it over, I should put it in the middle, shouldn't I? I'll put it there. Right, and the first two things we have to do, and I just had some wires, is we have to attach the power to this. So I'm going to look at my little diagram, and the ground goes to the top. So quite often these things have dual power supplies, so they have to have like a negative voltage that goes below ground and a positive voltage, but they're all kind of the same thing. I heard a good discussion about this. I got this the wrong way around, haven't I? So I should, where's my little chip? Oh, I took it out anyhow, it's fine. I only bent one leg slightly. I want to get it the same way as that I'm looking at it. So the top one in the middle is the ground or the low voltage. Yeah, that basically dual rail and single rail or single supply op amps are essentially the same. What really matters is that the single ones are much better at taking inputs that are closer to the supply voltages and supplying things at the outputs being closer to the output voltages, or something like that. But yeah, today this is a single. This is a LM324 is marked as a single supply op amp, so it should work fine for this. So now we've given it supply. I should turn it off while I'm doing this. So now it's got power going into it. Hopefully I got that the right way around. Though I have a lot of these ICs, seem to have accumulated quite a few of them, which is why I want to do some stuff with them. I know they're not very exciting in today's modern electronics, but they are still quite interesting. So what I'm going to do is I'm going to turn this one around, and I've got to get this just right. So, alright, now we need some wires. So I'm going to use purple for no reason for both these things. So one of them is going to go, they don't quite fit. I'm going to use purple because they're sitting right next to me. So the two supplies are going to be given in purple, and one, I'm assuming if you look at the bottom of this, that this one is, where's my little picture? Oh, I've lost my picture, but you can remember it. The little tap into the middle part is going to be the middle pin here. That makes the most sense to me. But I could be wrong, but we'll find out in a second. And so that one can go to the negative voltage. Oh, it's falling off. We can actually just test it in a very straightforward way. Because you can use them as, I don't even know what these go up to. It says on the side, reading this, 502, and then 13 upside down. So I guess that means it's, I'm going to guess it means it's 5,000, so it goes up to 5,000 ohms resistance. So if you had it all the way to one side, so if you actually measure the resistance between here and going through to the other side, I think I'm going to need my little picture. I think that's what this one means. The total resistance all the way across it is 5,000 ohms. So at any point you're tapping into it, the resistance on one side plus the resistance on this side is going to, on the other side, is going to add up to 5,000. But maybe you end up with 1,000 here and 4,000 here. In this case here. So I think I'm just going to put, you're going to be kind of pushed, I think, to actually get much light coming out of this. I'm still going to use the 470 ohm resistor to go to ground. So, and then we're going to use this little wire here. So this purple wire is going to come from the middle, go through to here just temporarily, and I'll turn this on, and it's not doing anything at all. And I'm going to use my little packet of screwdrivers I just bought recently. So I think this one will be fine. So I put that in there, and then I should be able to adjust this, and at some point you can kind of see that the light, you can alter the, so in this case here we're kind of ignoring that you can take one of these wires out. You can take the wire that goes to ground out and nothing's going to happen. Oh, I lie. No, it will, something will happen. Oh no, I don't want to do that, do I? It's not the best way of doing things, is it? That actually works a lot better that way. Yeah, so you've got both sides. That's the easiest way of explaining this. Well, when you got the positive voltage, it's going through this resistor, and then it's going into here, and then it's going off to the LED part, which is over here, and then the current's being split up into two, and it's going into here as well. You could actually just get rid of that bit and then not connect it up, and so you've only got one thing going from the positive voltage and going through there, which is what I just did. But it's always, the LED is always going to come on if you do that, because there's always a path, and the resistance is, I would think you can make it go quite dim. I'm going to take that off yet again. So if I take this off, so if I put it all at 5,000 ohms, so that's with 5,000 ohms resistance. These LEDs are so annoying, they just come on with anything. So that's actually with 5,000 ohms of resistance going through the positive, and that's wound all the way to one side, if it is 5,000 ohms, and then going through another 470 ohms, and it's still reasonably bright. So that's a bit annoying. So it's kind of interesting why it does go to dark to blackness. Oh, I know why. Because that's bad. Why does it not blow up when I do that? And it wouldn't, would it? Because the resistance, so at some point what happens is that the resistance going into this part here is much lower than the resistance here. So most of the current's just going through here in this case. Instead of going... So that might make sense. You've got 5,000 going through here. You've got 0 going through here. And you've got 470 going through here plus the LED. And so at that point it goes dark. So that's why that works nicely. But anyway, we still haven't got where we want to go. Right, we've been going on. We've got 8 minutes left. I actually wanted to do so much and I thought, I'll never get through it. So what's the point? Alright, so anyway, we are going to take this and that is going to go into one of my, we're going to use this one here. Alright, so I want to go into the negative input or the inverting input for the op-amp number 4, which will be pin 13, which will be that one. Right, and then I'm going to need some more. We're going to use the big stupid wires. Alright, so that's the... I feel like I should have used the black one for that. And now we've got to get out my LDR. So this is where it's going to get tricky, right? Because I don't actually know what resistance. And foolishly, I've left my thing miles away. By thing, I mean... what's it called again? Oscilloscope, not oscilloscope, multimeter, right, miles away. So what's this one? This one is, I'm going to read this, I think it's just a 1000 ohm. I'm pretty sure these have quite a lot higher resistances than that. Well, okay, what have we got here? I want to set a 10k. 10k sounds like a good, this is 100k. That sounds like a bad bet. It's a 10 ohm, it's like a terrible bet. What is this one? 5,000, okay, 5k. So we're going to use this to make our voltage divider. So I'll probably put it like this, so that it looks a little bit like a voltage divider. And we've only got 6 minutes. I was doing that thing where the camera is not looking right. Alright, and then that one is going to go to the positive. That one's going to the negative. That's the way you should have done it. Okay, so this is making a voltage divider through here. So positives going in through here, then through the LDR down to ground over here. So now we can tap that with the black one by putting it into here. I bent it already. Alright. So that one's going to go in there, and that's going to go into my positive input, which is pin number 12, so it's going to go right next to there. And then we are pretty much done. We only have one more thing to do, and we're going to use a purple wire. I think I've moved, no I haven't moved everything. Okay, the purple wire is going to be my output, and that's going to go into there. So now we have to adjust this. So hopefully at some point, when I'm adjusting it, the light will come on. If not, this is disappointing. And nothing is happening. Alright, so what we will do is, where's my 5? So the first thing we can do is to test that it works. We're going to take out the LDR, and then we're going to put in another 5,000 ohm resistor. So what we should be seeing is about 2 volts. I'm going to have to get up and go get my multimeter, aren't I? Oh, actually, we could use, if I can find the things for it. Okay, we're going to use this one. So I picked this up recently. It's a very, very tiny multimeter. I'm running out of time here. But anyway, so that's going to there. So that's going into the positive input. And that's going into... Did I even turn it on? Maybe that's why. Did I not turn it on? Oh, I've got the funny feeling that was what I did. Okay, so at some point, when I get about halfway, the light should go off. And it does. So at this point here, on this potentiometer, I'm getting to about the halfway point, and then it doesn't feel like halfway actually. It feels a lot less. So that's annoying. I'm pretty sure that the input resistances, impedance on this is something like 2 million ohms or something. So it shouldn't be affected too much by the fact that it's only 5,000. Remembering all our parallel circuits and series circuits and resistances and stuff. So that kind of works. So let's quickly replace it. We're not going to use this thing. I don't actually know if it works very well. I haven't never tried it. It does turn on. Alright. So now we've plugged this in. And at some point we can turn this so that the light comes on. Alright, so it's about there. So if the light's on, if I turn the lights off, it still does that. And if no, we can't get it to turn off though. Have I got this done right? Oh no, I haven't. Okay, that would be why. All right. So, oh, there we go. It goes off when the light goes near it. So, which is kind of what you want, isn't it? So I think we've just actually done it with 2 minutes left to spare. So the only problem I just had then is that I plugged it into the positive rail, so that was always a positive voltage going into there. And it's kind of annoying that it... Well, that's what you get, because these things aren't really designed to go all the way to the positive. So the inputs shouldn't go all the way to the positive rail value. So they shouldn't go to the positive supply value or to the ground. They can get kind of close, but maybe when you're actually forcing in... but it isn't going to be forcing in that. No, it's not, is it? Strange. No, that's kind of okay. That makes sense. I'm just talking about what happens if this is going into the positive voltage, into the positive rail, and that's going into the positive rail. And now it's going into the negative rail, and this is going into the positive rail. And so it appears that this, if I turn the lights out, the light comes on. And if I turn the lights on, the lights go off. Lights come on, lights go off. So that's kind of what we want. If you change it around, it will in fact be... so that's a bit strange. Oh no, there you go. And it comes on quite well. The thing that I wanted to mention, which we will mention, because it's going to lead into the next thing. Oh no. What, you're just going to... Oh, right. I thought it was my finger. But there should be a point where it should come on. And you can kind of see, I don't know if you can, but it kind of flickers a bit and it's a bit dim for a while, so the crossover isn't perfect. So I was going to try and go over how to make it a sharper crossover, but it actually works quite well. But we're going to look next time into a thing called hysteresis, and adding that into the circuit, so to make the crossover more sudden and solid and not sort of flicker around. So you don't want it to be in that flickery state, which I don't think is going to even show up on the camera, but it is flickering. Anyway, I hope that was kind of interesting. It was a bit all over the show. We've got lots more exciting bits to go with this, but thanks for watching. Like, share and subscribe, but we are all out of time.